Continuing on with our 9.1 lesson, we're now going to be looking at complex fractions. Now, a complex fraction is a rational expression where both the numerator and or the denominator is a rational expression. And by that, I mean, if we look at this one, our numerator of this big fraction, our numerator is a over 5, and our denominator is just 3b. So this is a complex fraction because the numerator is itself a fraction. Same thing over here. Our numerator is a fraction over our denominator, which is just a polynomial. Now they can get even more complex. If this is our big main fraction here, the numerator is a fraction and the denominator is a fraction. Or they can look something like this, where this numerator has a fraction added onto another piece, so does this denominator, a fraction, subtract another piece. So they get pretty complex. It's kind of like a taco, inside of a taco, inside of a Taco Bell, inside the food court at the Mall of America. It can get pretty deep. So remember though that a fraction is just a way to express a division problem. So you can express things as, you could write it as x over 5, or you could write it as x divided by 5. So let's say our x was a fraction itself. That would be 1/5 as a fraction over 5. We could write that as 1/5 divided by 5. So again, the rules of division apply to these complex fractions, because that's all they are, it's just division problems. So let's see how one of these works. If we have to simplify this complex fraction, for me, I think one of the easiest things to do, or the best helps, is to kind of draw in and darken in that middle bar so you know exactly where the fraction is kind of stopping. Then we know that we're focusing on this piece as our numerator, and this piece down here is our denominator. Okay, now that we have it broken up in this way, bring it over here, and we'll break it down into these pieces. X squared over 9x squared minus 4y squared divided by x cubed over 2y minus 3x. Now it's a lot easier to deal with. Now it goes back to just being a division problem of our rational expressions. And we know where to go from there. We can just break this down into x squared over, well actually, I'm going to break this down right away into, I can notice that it's a difference of squares. So we'll break this into factors as we're going along here. 3x plus 2y and 3x minus 2y. Because it's a difference of squares, so these are going to become our factors. Also, because this is a division problem, we're going to change it to multiply by the reciprocal. So we'll flip those around. It's 2y minus 3x on top and x cubed on bottom. Now again, one more thing to notice is 2y minus 3x. We can pull the negative 1 out of that. Negative 1, and that makes negative 2y and positive 3x. That's going to be the same as this piece over here. So when we pull that negative 1 out, that'll change up the fraction, and commutative property of addition means we can flip these two around. So it would be 3x minus 2y, which means it's the exact same as, oops, get rid of that, exact same as this piece. Also, crossing out diagonally, we can take out the x squared and leave just an x1 over here. So now, it looks like we're simplifying down to our top. Our numerator just becomes negative 1. Everything else was canceled out. Our numerator is just x times the factor 3x plus 2y. So this is our most simplified version of this complex fraction. And that looks like that's everything.